this video, we show the practices that support ongoing changes in student thinking. The first of the practices is introducing ideas that students can use to reason with in the upcoming activity. The second is engaging students with an activity that generates observations or data. The second practice requires that students use the introduced ideas from the previous practice to reason with. The third practice is using this new knowledge to revise models and explanations for the anchoring event. This set of practices would be used 4 or 5 times throughout the middle of a unit to help students make cumulative sense of activities, investigations, and readings. We'll see Anna integrating several scientific practices together in this lesson and the next. Previously, her students have created models of the distillation phenomenon. This has generated questions about the nature of heat. Anna will now help students design an investigation that can clarify how heat works. With the resulting information, her students will return to the model and make changes to
it. Your entry task is just what your ideas are about what heat is. Pre-reminder, while I'm listening, you also will be listening to what your classmates have to say. Okay. So, first person is Milan. What did you write, Milan?
I wrote that heat is a warm air that is made by the sun's heat.
That's a bummer. I didn't hear what she said. So, please repeat it one more time.
Heat is a warm air that is made by the sun's heat.
Warm air that is made by the sun's heat. Who else wrote something about the sun? Yeah, I saw a lot of things about the sun. Victor, what did you write?
Heat is molecules that move fast.
Heat is molecules that move fast. Who else heard about molecules? Anywhere in their answer, molecules. Okay. So, Victor, tell me where you got that idea from. What are you thinking of when you think of heat being molecules that are moving fast?
Wait, what do you mean?
So when you look at that sentence that you wrote, what does it remind you of? Anything from class? Anything outside of class?
Class.
So what from class?
A video you showed us.
Which video?
A video on middle school chemistry, something like that.
Do you remember what the video showed?
Molecules. They were moving fast when it was solid, it was still, and when it was warm, the molecules were moving.
Okay, so that was like a lab?
Yeah.
Okay, so that's a cool connection. Alright, so Tin and Bless, I wanted you guys to share what you wrote.
Heat is something that is hot. It comes from fire, from boiling water. Also, molecules in heat move super fast, and molecules in cold things.
Oh, okay. So this is similar to what Victor was saying, right? Okay. So you gave more examples than he did, though, didn't you? Can you tell us what those examples were one more time? The examples.
Boiling water.
Okay.
And fire.
Boiling water and fire. So have you guys seen boiling water before?
Yeah.
Yeah. What does it look like?
The experiment that we did.
7. No.
Okay. And then they talked about the movement of molecules, and they actually went even further than Victor said. They said molecules are moving super fast, right? Yeah. Okay. So we've got this idea of heat having something to do with molecules and their speed. And you guys agree that the speed is super fast. It's not slow, because you're talking about cold being slow movement. Okay, cool. Anybody have anything they want to add that we haven't brought out? Anything that you need to add before we move on? Okay, so today we are going to start a 2-day entry, like I said. Our goal at the end of it is to be able to write or draw our own scientific definition of heat. So we're going to come to an agreement as a class about what heat is. Okay? And we're going to be able to draw it write it. Then we're going to put it on our word wall so that we have it to use as a resource. Okay. Yesterday, we threw some Post-its up on this model that we have. We're trying to explain pieces of this model. So, look at number 1, 2, 3, and 1, 2, and 3. And you can see that I've had time to organize those Post-its into big stacks. So the big stacks are things that people are trying to explain that are the same. So their ideas might not be the same, but the thing they're trying to explain is the same. Look at number 4. What do you notice about poster number 4?
It has a lot.
It has a lot. It's covered in Post-its, right?
Yeah.
So that's what all the posters looked like yesterday. So there are a lot of ideas up there. Okay? A lot of those ideas have the word heat in them. So that is why today we're starting with what heat is. So you guys decided what we're learning today. Because you showed me that we have all these ideas, they have to do with heat, we need to know what heat is. So what we're going to do today, in the little experiment in front of the class, I have a piece of metal. In that metal there's some wax, and the toothpicks are stuck in the wax to hold them on, okay, so they won't fall.
Would they break?
They would if you touch them, that's why I'm not letting you touch them. Okay? You'll get a chance to see it, super close. So what we're going to do is we're going to hold this over the flame, so we're just heating one end. And we're going to just kind of see what happens to these. So, question, what happens if that wax melts? Just shout it out.
It falls off.
You know. These will fall off. So that's kind of going to be our indicator that this metal's getting hot. So we're going to ask some questions about how the metal heats up. If I light this end of it, is it going to travel down, or is it going to heat the whole thing? Are they going to fall off right away? Is it going to take a while? We want to know what's going to happen. So just like any other time that we do an experiment, we've got a paper that we want to fill out first. We want to identify all the parts. So when you get this paper, please put your name at the top and read our investigative question. Read that question at the top. All right, let me show you what we're talking about. Let's all get on the same part of this page. So we are right here on that investigative question. Remember, this is what you're going to see when you take the MSP. We're going to work on translating that into words that make sense to you. So I don't want you to answer the question, I want you to translate the question. So you're translating it into everyday speak. Okay? So you're taking it from science language and you're putting it in your language. So, does anybody have a guess at what might be a good way to restate this question that doesn't use as many science words? Start over here, and then we'll go this way.
How heat comes from one object to another.
Okay, so I'm going to add a word. I'm going to add how does heat come from one. You don't even have to use the word object. You can say one thing to another.
That's what I did.
Cool. Alright. Roll.
Yeah, you write that.
You get to choose the one you write, so hold out for a second.
One object pass the heat to another object.
Alright, these are still pretty wordy. Do we have anything shorter? Yeah.
How is heat moved? Wait, how is heat moved from one particular element? How does heat move?
I couldn't hear you.
I don't know.
You take him back to raise
Well, I
hand.
know how to explain it, but
Well, just what's the question that you're thinking of?
I don't know if I know the answer.
Oh, you just got answers for this? Alright, so anybody have another question before we move on? Because Henry's ready to do the prediction. Any other ones? So think about what you think will happen and really try to explain why you think that'll happen. Alright, third period, I'd like your full attention in 3, 2, 1, 0. Alright. When I ask for your prediction, all I want you to do is read what you wrote. You don't have to change or add any detail. Alicia, what did you write?
The candle heating the metal metal will get off, so it won't heat it, and then it will melt the wax. The metal is hot.
Okay, so there's certain steps to what will get heated first? Is that what you're saying, that the metal will get heated first and then it will heat the wax? Okay, so it's gonna be in steps. Cool. Let's hear somebody else's prediction. Thanks, Alicia. Looks like it's Alicia again. Okay, Henry wants to share. Go for it, Henry.
So the candle, right? Like the flame of the fire thing will burn the metal. Then when the metal gets hot, it's gonna move to the side and make the what's the thing that's holding the
The wax?
yeah, it's gonna burn the wax and the wax will melt.
So you agree with Alicia that it's gonna go step by step? Okay. How will we get heat on all the metal?
Now, if you heat the one side right, it's gonna start burning through it's gonna move all.
Okay, so it's gonna move down the middle? Okay, Alana, do you wanna add to that?
It's the first toothpick because it's closest to the end of the metal getting burned.
Okay. So can you take what you just said and connect it to Henry's idea that the heat is gonna move down?
It's gonna start from the end. The molecules are gonna start pushing them onto the next molecules. It's gonna go all the way to the end of the metal, and it's gonna burn the wax on the first one.
Okay, so now everyone has to stop and look up because something has happened that I'm not sure you heard. Okay, part of it was because Alana was speaking really silently and some of you weren't paying attention. Okay, I'm not going to make you repeat what you said, but what Alana just told me, he went from describing what he could see right here to talking about molecules. That's a huge step. Okay, so now Alana's not just making a prediction about the setup that he's going to be able to watch. He's actually thinking about the parts of it that he can't see, and he's making a prediction about that. Okay, so the part that he said was that molecules in the metal, I forget the exact word you used, was it thump? Push, is that your word? So he said the molecules are going to push the other molecules. So let me make sure I understand what you're saying.
Passing heat on the next molecule.
Okay,
It's
but
it's a solid. They're all pushed up and it's easier to shoot.
okay. Well, that was some good science that just happened in your brain. So there's absolutely no reason why anyone should have a blank prediction right now because we just got so many awesome ideas from you guys. Alright, so what is our manipulated variable? What is the only thing that we are changing about these toothpicks? First, can you say that super loud, what you just told me?
The distance from the candle to the toothpick.
Why would that be something we want to control? Sorry, don't use that word. Why would that be something we would want to set ourselves?
See which one off faster.
Okay. All right. So, Curtis, you just told us what we're looking to see. So, what do we call that? What variable is that? What we're trying to record or measure?
Responding.
That's the variable we're measuring. So let's organize all this and get it onto our paper. So what are we measuring? What are we going to record? I'm going to go with Jose since I haven't heard from Jose yet. What did you say? What about the toothpick? How they fall and what's a good way that we could measure and get numbers?
How long it takes?
Sure.
It's actually the same questions that we wrote up.
It's exactly the same. Okay, that's not just, oh, it happened to be that way. That's how data tables get set up. So when you see a data table, you automatically know what the thing that you're changing or setting is and exactly what you're measuring. Okay, that's a really good trick to learn. So while I set this up, what I'd like you to do is choose one thing that you've labeled in this picture and draw a zoom in of what the molecules look like in it. So you're choosing one of these things and you're drawing a zoom in of it. So this might look like, a zoom in of the metal might look like this. When I light the candle, both Casey and Daniel are going to start the timers. Casey is not going to stop her timer until she sees a toothpick fall. Daniel is going to not stop his timer until he sees the next toothpick fall. I'm not touching it. Do you see space? Whoa! Stop, Casey.
Do it. Yeah, Casey, stop.
You can see him moving through the metal. The dark spot.
It's transferring.
Oh, that's
Oh, it's not
fancy.
gonna play. It's what?
Wax.
It's gonna fire in 5, 2.
Oh! Stop! Right now, you should be copying this data into your data table. Daniel, how long did it take the second one to fall out?
59 seconds.
So let's just go with 59. Alright?
That's almost a minute.
59.66 out of us. I want to know what your best explanation of this data is using the word molecules if you can. I'm going to give you about 2 minutes.
Wax, its molecules spread it spread it out more faster than the second toothpick wax because it reached the first toothpick first and the second toothpick like a little bit later. So the second toothpick took a little bit later than the first one for its molecules to like spread out and yeah.
Molecules go faster because the metal.
I said the heat molecules, they were going through, but it touched the first wax and it fell faster. Well, the heat molecules, when they got to the second wax, it was weaker because it was further from the the actual fire.
So does heat have molecules?
That's what I know.
Yeah, they do.
I think so.
Heat has molecules?
Every room has molecules. This table has molecules, but they're together because they're solid.
Okay. Okay.
Liquid has molecules.
All right. So write that down. That's good.
So one of the molecules are bouncing.
And then when they touch another one, it makes all of them they touch each other.
They touch each other. I hope you guys heard some of that. Janet's got a theory there.
Tin, what did you write?
I only wrote the molecules in the wax heat up.
The molecules in the wax heat up. Okay, so you're giving us a piece. So how is heat transferred from one object to another? Can you tell me where the heat was before it was in the wax?
The tin. Lighter.
Sorry?
Lighter.
The candle? Okay, cool. Elizabeth, what did you write?
The molecules on the flame heated up the metal and were moving really fast up to the toothpick.
Okay. Let's see. Vanessa, what did Elizabeth just say? Can you restate what she said or explain what her idea was? Do you maybe need to ask her to repeat it? Okay, go for it.
Right there. Can you repeat that? The molecules on the flame heated up the metal and were moving really fast up to the toothpick.
So what's her idea? Where does the heat start, Vanessa, according to Elizabeth? The flame, and then where does it go?
To the metal.
And then where? Okay, so now we've added one more step to our, to Tim's idea about where the heat is going. Cool, thank you.
The molecules get hotter and they get like racing.
And they get what?
They're like racing.
They're racing. Okay, that's a word we haven't heard before. What do you mean by the molecules are racing?
They're really fast.
They're moving really fast? Okay. Did anyone else write something similar to what Casey wrote?
Who's racing?
Janet? Can you read what you wrote, Janet?
When the heat touches one molecule, it starts to touch the other one and made it get to the wax, which made it melt and make the toothpick fall.
So, what I hear you say, Janet, make sure that I'm getting this right, is that the heat is actually, it's touching one of the molecules, and that molecule is touching another molecule.
And that molecule's
And that molecule is touching the wax. So it's just like a step by step all the way down. Kind of. So if you were to draw it on here, how would you draw it? What would you show?
Like when they bounce or something, they touch another one, which makes it like go hot, which makes it touch another one.
Okay. So I want us to stop with that idea, because Janet's idea that the molecules are bouncing, that was your word? Bouncing and touching the other molecules is a really good place for us to stop. Tomorrow, we are going to look at some animations and we're going to see exactly what those molecules are doing. So we're going to see what Janet's idea is all about. Okay? So that was great. Chasing Janet, I liked it. Your homework is to find something outside of science class that reminds you of something you saw in the Coke and 7-Up lab. Okay? This is up to you. These are your ideas. It can be anything from home, from TV. That experiment paper needs to get put in your journal.
You had a girl revoice something that somebody else said?
Yes.
And why did you do that?
Do you want me to be honest?
Take three. Take three.
Okay, so the reason that I had her revoice what Elizabeth had said is for practical reasons I wanted to hear it again, but also because I keep asking kids to listen when other kids share ideas as opposed to just letting them talk. And one way to show the difference between listening and letting them talk is to ask them to share what they heard. So that also gets kids who maybe don't have an idea or don't know how to put the idea or are afraid to share their idea. It gives them a way to participate as well, at the same time as making them consider someone else's idea, which they can do that when they hear it, but then if they have to revoice it, then they're considering it in a more authentic way. And it also gets I guess like those key words or the key parts of the idea restated again by another student, so it's more kids hearing those words again, I guess.